Let's suppose I take a conductor like this, in which I give a potential difference of V across the conductor. The point A and B is the endpoints of this conductor. For a potential of V, I know that whenever there is a 1 coulomb of charge is passing from the point A to B, then it does a work of V joule. So suppose that the work done by the charges when moving from the point A to B is fully converted as heat. And for a steady current, for a steady potential, there will be a steady current will passing through this conductor. Let's suppose it is I. And my goal is I need to find the heat generated per second. How can I find? We know that when 1 coulomb of charge is passing from the point A to B, it will do a work of V joule. When I current pass, then it will do a work of Vi. This I coulomb of charge is passing per second. That means per second this much work will done. That is, this much power will done by this circuit. So in this point, I am giving you a question that what should be the maximum value of this power? Let's pause this video and try to think about it. Okay. For that purpose, I need to find the relation between V and I. How we can find the relation between the V and I? In this case, the Ohm's law comes. Ohm says that whenever there is a conductor in which the potential difference of V applied at the endpoints, then the V is directly proportional to I. This is the Ohm's law. Or we can say that V is equal to I times R, where R is the resistance of this conductor. That means that how it resists the flow of the charges. More R means more it resists the flow of the charges. So by using the Ohm's law, can you find what will be the power in terms of V? That is, if I apply potential of V across this conductor, how will be the power look like? Well, we know that whenever there is a potential of V applied, then I times R will be equal to V. That means that if you just put I as V by R, then we get the power in terms of V. That is, power will be equal to V times V by R. And this will be equal to V square divided by R. This means that the R is a constant. We need to increase the V, we can increase the power. So this is a not bounded function. That means that we can increase the power as much as we wanted. So in my previous question, there is no answer for that. Let's suppose I connected two resistors in series. The series means the point-to-point connections. Let's suppose it has a resistance of R1 and it has a resistance of R2. So there is a potential difference of V applied to these two resistors combinedly. That means if 1 coulomb of charge is passing from this point to this point, it will do some work, and the same charge while going from this point to this point, it will do also some work. But the total work will be equal to V. So let's say it has V1 and it has V2. Then we know that V1 plus V2 is equal to V, the total work. And suppose that there is an I current is passing through this circuit. So what should happen? This I current will pass through this resistor and will pass through this resistor. So what Ohm says? Ohm says that the V1 will be equal to I times R1. In this case, Ohm's law. If you forget, then Ohm will kill you. That much strongly Ohm tells this thing to you. So the same current is passing through here. That's why we can say that V2 will be equal to I times R2. In this time, I am asking you a question that what would happen if we replace a new resistor of R3 resistance here? What happens if I passing the same current I through it for the same potential? Then what will be the value of the R3? Well, we know that from the Ohm's law, the potential difference is V. That's why V should be equal to I times R3. And we know this equation also. So just put this in this. We would get R1 plus R2 will be equal to R3. And this R3 is known as the R effective. That is the effective resistance. It means that whenever we place a new resistor by replacing all the series one, then we would get the value of the R effective as the summation of all the series one. Let's suppose that there are n resistor that are connected to seriously connected in series, then what would be the value of the R effective? Yeah, that's the sum of all the resistor, that R1 plus R2 plus R3 plus dot 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 Rn. So this is a way to find the effective resistance when the resistors are connected in series. Let's take another condition in which we are connected the resistors like this. It is the R1 and it is the R2 and this is the R3. Oops. Okay. In which it is a parallel connection. This means that the wire gets divided. This is a 3 conductor that is connected in parallel, but in order to show the examples of the parallel, we need to have a simple case, that is the 2 resistors are in parallel. Let's say it has a V potential and it has R1 and it has R2 resistance. So we can look at what happens, what's going on here. If you connect it like this, then there will be a current I will flow through this. So at this point, what would happen? Let's say this yellow wire does not have resistance. That's why there is no work done when the charge is flowing through this wire. So from here, if you take 1 coulomb of charge and pass through this resistor, it can reach at this point. And from this point, it has 2 choices, whether it can go to the battery back or it can go to the resistance R1 back. It will go only in this way, not this way, because it is in this way it is a higher potential. This battery will not allow it. It will push it away from here. That's why it will not happen. Similarly, the charges from this point through this R1, at reaching this point, it can go in this way or in the downward direction, but it will not go this way because of the same reason. The potential, higher potential, the charges will only goes to the lower potential. So we can say that if 1 coulomb of charge is passing from this point to this point, it will do a work of V joule, because no other work will be done on this path. This wire does not have resistance. Similarly, here also it will do V work. So V be the potential difference between these two ends. And let's take the current in this direction will be I2 and in this direction will be I1. And we know that the total current is I. So I will be equal to I1 plus I2. So how do you find the value of the I1 and I2? From the Ohm's law, we know that the Ohm comes here. Ohm says that the V should be equal to I2 times R2, because if we consider only this resistance, that it has a potential V and I2 current is passing through it with a resistance R2. And we can write also V is equal to I1 plus R1. In this case also we can apply the same principle. Now my question comes. What would happen if I place a big resistance of R effective here, in such that a current of I is passing through this resistor for the same potential V? Then how do we find the value of the R effective? Yeah, we know that from the Ohm's law also, that V is equal to I times R effective. This because this big resistance I current is passing for a V potential, and we have these 4 equations actually. So how do we find the value of the R effective from this equation? Yeah, just put this value of the I here and just the value of the I2 here and just the value of the I1 here. Then we would end up with 1 by R effective will be equal to 1 by R1 plus 1 by R2. From this equation we can easily find the value of the R effective. So what would happen in the case if there are n resistors that are connected in parallel? Then what would be the value of the 1 by R effective? We can derive it same as the way in which we have derived the previous case. The 1 by R effective will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus dot 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 1 by Rn. This time I am giving a question such that I construct a circuit like this, in which it has a potential of V I applied, and then there is a current of I flowing through these resistors. These are 3 resistors in which it is R1 and it is R2, which are in parallel to each other, and this parallel circuit is connected to a series resistor. This R3 is in series with this parallel circuit. Then my question is, what would be the effective resistance of this system? The term effective resistance makes some confusions in your mind, but remember folks that the effective resistance means if you place a resistor here, it has a resistance of R effective. For if I give the same I current through this resistance, then it has a potential difference of V. That's only the concept, nothing much. So how do you find the effective resistance of this big circuit? Let's take the parallel ones. These are the parallel ones here. And let's suppose that it has a potential of V1 and it also has a potential of V1. These two resistors are in parallel. And it has a potential of V2. And we know that V1 plus V2 will be equal to V. This is a key point here. So if I place a resistor here such that if I passing the I current through this resistor, it does a work of V1. Can I find like that? Yeah, it is a R effective of the parallel ones. These parallel ones are effective is this big one such that I pass a I current through it. It has a potential of V1. So what will be the next step? Yeah, we can see that these two are in series. This I call it as R effective of parallel ones. Okay, these two are in series. So if I find the effective resistance of series of these two resistance, then I can just write as R effective of this big circuit will be equal to R effective of the parallel one plus the resistance R3. Then if I pass an I current through it, it has a potential difference of V, that is V1 plus V2. Try to find out this answer.